Hey, so thanks so much for coming, everyone. Seems like we have a lot of people coming in. So let's try to get started because we have a lot of content to cover for today. So I'd like to first introduce Mr. Gabriel Chan from the Hong Kong Blockchain Society, who is a solution architect as well as a blockchain extraordinaire. So I always have a lot of interesting discussions with Mr. Gabriel. Um, so I guess I can pass over to you now, Mr. Gabriel. So the floor is yours.
Sure. Should I try to do a screen share?
Yep.
I think I need a permission. Okay. Should see my screen now. What does it say? Someone
Crash
read it to me.
course.
Good. Okay. So this is going to be a crash course. I was told that we have an hour to cover everything we need to know about blockchain solutions. Okay. So we haven't tried that before. Usually this takes like several days to do or months. Okay. But I heard you guys are very smart. So let's get going. So the first message to tell everyone is engineering is easy and it's people problems that are hard. Being an engineer myself, I also fall into this trap. We tend to think that technology can solve everything. We build it and people will come, or we build it and things will be done, but it's not the case. Coding is actually quite easy to plan and to create things. It's what we choose to create and how those systems interact with people in the real world. That's a hard thing. So that's why we want to tell you all about the blockchain solutions design and why that's important. So that being said, though, we're going to first run by some technology fundamentals because I'm not sure if everyone has heard about blockchain or have this same idea of what blockchain is. So let's just start from scratch from there. Secondly, we'll run through the solution fundamentals, some ideas of what blockchain solutions, some components and some aspects that things should have. By the way, if you guys have any questions, please dump them in the chat. Someone from PolyHack will moderate and ask me on my behalf. So on your behalf, sorry. And finally, blockchain challenges. So today, I think we'll have enough time to cover three. If we're lucky, we'll go fast and furious. Okay, so please bear with us. So first, some blockchain fundamentals. Why blockchain? So long story short, blockchain solves the double spending problem. Okay, so even in the first Bitcoin paper from Satoshi Nakamoto, we propose a solution to the double spending problem using a peer-to-peer network. Okay, so what the heck does that mean? So double spending is a problem where you can, long story short, spend money that you don't have. So in the digital world, copying and pasting is quite commonplace and easy, and that's one of the benefits of digital. But in the real world, you cannot copy and paste money, and even if you magically could, then the economy would collapse and that system would cease to function. If then that's the problem with digital money. So there's must be some way to do this double spending. To prevent double spending in the digital world. Okay, so in the past, they've tried some solutions, and they happen to be centralized bookkeeping solutions. And Bitcoin, for the first time ever, they proposed that there is a peer-to-peer way to do it. So essentially, it's a decentralized bookkeeper. So the problem with centralized bookkeeping is that the bookkeeper would be able to know everyone's transaction. That is a very powerful. It's very powerful, and with great power comes great responsibility, apparently. But this is not the comic book world, so yeah, good luck with that. And that's not going to happen. So decentralized bookkeeping then is a quite novel, and for most people, it's a good way forward. So another reason why central bookkeeping doesn't work is the bookkeeper could censor transactions and censor parts of the system altogether. So yes, great power, great responsibility, handled carefully. Now, all this being said, many of you may have heard that blockchain is all about decentralization. Okay, so if we ask Scott, are you still here? You could be my representative of the audience. So if I were to ask you, let's say I'm asking you, what is the definition of decentralization? What does decentralized mean? What would you say?
And okay, it would be the fact that information is like distributed. So you
This,
have a
well,
ledger where everyone has a say in bookkeeping.
well, not exactly. So a distributed ledger and decentralization is two different things. Distributed means it's more of a physical separation. You can be distributed and still centralized, like how Google works, basically, like Google Cloud, right? Yeah.
Mhm.
Anyone, maybe your team, would they want to take a try?
Yeah, sure. Or anyone in the audience. Guys,
Yeah, or anyone in the audience.
feel free to open your mic and share. Okay, we have a question not related to the topic. Yes,
Yeah.
it is recorded. We'll be on YouTube as well.
Okay, cool. How about Anif?
Yes, hello.
Yeah. What do you think decentralized means?
Same thing as what Scotty said, as when it comes to centralized system, everything's sort of central around one point. But in decentralized system, everything's sort of distributed evenly. At least that's what my perception about it is.
Okay, that's fine. And so how do you have an opinion? Maybe we can give you.
To be honest, I'm not sure what the right answer is.
It's okay.
Thing. Yeah, the most I know about decentralization is on governmental systems where you would have power not being held only in the capital, but in cities or in states and things like this. That's the closest I can get to it.
Yes, that's a good analogy too. So there are some highly centralized governments and relatively decentralized governments, right? So for example, China would be like a very, very central government. So would Russia, right? Spain, for example, right? Spain is highly centralized as well. Something very decentralized in comparison would be, for example, Germany, Canada, United States. The provincial and states have more power from the federal government. As hard as that seems for the U.S. government, but that's actually true. Like, for example, marijuana laws, right? Where is it legal or not? Every state has their own policy. So yes, Matthew is this is the answer that I was looking for. No central authority, but this is actually the answer that is commonly given and not exactly true. Decentralization doesn't imply no central authority. In fact, decentralization means there is it is a process towards moving towards decentralization. I know that I defined something with that word, but everyone knows in English what does decentralization mean, right? And what I'm trying to say is that decentralization is not a destination; it is a journey. As a process, okay? There's no such thing as 100% decentralization. It's only about a balance of how much decentralization and centralization you need. So even in a blockchain solution, there's inherently centralization, just what degree. Like, for example, Bitcoin, how decentralized is Bitcoin? This would be an argument right here, and we don't have time for that right now, to talk about it later. But you hold one Bitcoin conference, and basically all the miners in the world show up in the same place. So really, how decentralized blockchain, right? That's another issue. But centralization also is not necessarily good or bad. Just like decentralization, not necessarily good or bad. It's all about striking a balance. So if anything you want to take away from this training, please remember that the world is not black and white like this. So why blockchain? Another reason is we're moving to an internet of value from an internet of purely information. So what you might remember as, or know as the internet now, or the World Wide Web rather, is its websites, things are served to you. Web 2.0 is like you can contribute to the websites, and it serves stuff back to you too, right? But you don't actually own any of that stuff, right? The companies do. Like Google owns our account. Google, forgets your password, you are gone. Okay, so that's the essence of the web and internet right now. The future is that there's an internet of value. So it means that you can own stuff, not just but you own, like literally you own. So that's a very big difference. So that's opens a whole big area. So this is also a paradigm that some people are using these terms. Okay, Web 1.0 is read only, like go to a web page, serves you a web page, done. Web 2.0 is like, for example, YouTube, right? So you can read, you can write, you can share. Okay, Web 3.0 or Web 3, there's still some, debates on what this really means, but in general, it's, you own the stuff that, you own your own assets on the internet, and this is made possible with blockchain technology. And blockchain is just one component of this ecosystem. Now, what is blockchain? This is a recap. Blockchains rather, is technology, helps those that don't fully trust each other to form and maintain consensus. What that means fully don't trust each other is they need to work together, for example. They might be friends, colleagues, allies, not colleagues, rather. Colleagues is in the same organization, they don't need a blockchain. But allies and partners, right? They may trust each other enough, don't fully trust each other because they're in different organizations. They need to form and maintain a consensus. They need to agree on some sort of truth. This is why it's called single truth. There's an absolute truth. We're not talking about religion or philosophy here, okay? It's a truth good enough for this group of organizations of people, etc. And such that the existence and status and evolution of shared facts, this is maintained by everyone. So everyone sees the same thing, trusts the same thing, and works on the same thing. So this is the basis of blockchain technology. So everyone sees the same thing because there is cryptography and shared ledger, and everyone agrees on the same thing because consensus, like the entire network or group, comes to a consensus of what they would say this is what's happening now. And finally, shared contract. Everyone sees and trusts the same thing, so we work on the same thing. So shared contract, or commonly maybe you heard the term smart contracts, right? That's just simply computer programs running on blockchain, or the computer program is committed to the blockchain. There are reasons to do this and reasons not to do this, of course, but we won't get into that detail for this lecture. Okay, so blockchain solution. Oh, before we begin the next section, any questions, maybe from the exec or from the audience? Good, thumbs up. All right, here we go. All right, so blockchain solution.
We have one question from
Yes, go ahead.
Wong.
Yes, go ahead.
He's asking what's the difference between torrenting and blockchaining?
What's the difference between
torrenting and blockchaining?
Torrents are inherently a centralized, that's a good question. Torrenting is another protocol for file sharing. It's inherently, how do I say this? There's no consensus in the torrent protocol, okay? There's a file, and then everyone has a file, can host it and serve it. Blockchain is actually more than that. There's a governance dimension to it, that everyone has to agree that this information contributes to our single truth. In fact, when someone says, hey, I have a blockchain solution, therefore you can trust all the data on it, right? Well, not so fast. How was the data entered into a blockchain in the first place? And if it wasn't entered in a way such that the largest majority and the minimum viable majority believes that this is trusted information, then there's a problem. Whereas in BitTorrent, or those file sharing protocols, like you upload a file, you claim this is, I don't know, the latest anime collection or whatever, right? I can't think of what other things torrents would be used for, honestly, right? You don't actually know. And how do torrents manage trust, right? Through comments from people that they have a system, okay? System that works well enough for them, right? But it's nowhere near the same kind of trust that you would inspire to have with blockchain. It's an interesting question because most people may find a comparison between BitTorrent protocol and the IPFS, Interplanetary File System. They work in very similar ways, but there are some differences. Whereas the BitTorrent protocol is it's hard to explain this, and it's not as important in this context. I remember reading a Reddit post about this, and on Hacker News, people explain it a lot better over there. So I would look for like Bitcoin versus IPFS. So this is IPFS versus Bitcoin. That one explains it quite well. IPFS, although it's not blockchain, it's something quite useful for blockchain solutions, which I would get into in this second set. Okay, because you want to store things in a blockchain solution, but you do not want to store things on the blockchain. Blockchain is a ledger; it is not a database. Well, it shouldn't be used like a database. Well, because IPFS belong to Web 3.0, I mean, it enables a lot of the things that are promised by Web 3.0. I think it's not too important to delve too much into those labels of what is Web 3.0. But leave that for the scholars. We're here to hack stuff together, right? We're here to build stuff. Okay. So, but yeah, in general, people would consider IPFS as a Web 3.0 thing because it enables users to own their own stuff. That's takeaway. Censorship resistant, yeah, just like blockchain. But in general, remember, do not store things on the blockchain. You want to store things off chain. So if you need to store things off chain, then IPFS is an option. Then local storage would be an option. But there are pros and cons to each. That's a very long discussion. Anyways, any other questions?
But IPFS belongs to Web 3.0, right?
Yeah, you can say that. Long story short. Yeah. Okay. So now let's dive into the solution fundamentals. Okay. So back to the very beginning again. Always start history, right? So this cartoon was I think published in 1995 or somewhere around that time. Okay. So this was when the internet was first made to the public. Now the internet was invented by the US military. It was meant to connect computers that were scattered across the country. As you know, US is a very big country and computers were also very big at the time. I mean, they take up like entire rooms, right? And also very expensive. So the only people with computers were like, either the military or military researchers, which is, universities, okay? So on the internet, no one knows your dog because they don't have an identity layer for the internet. And it's not needed because you know that, oh, this is Stanford and you kind of trust. So the internet at that time was like kind of a private network as such, right? So when the internet was made, for public use, that architecture still remained and there was no identity layer and no one knows until it was too late, okay? And it's too late. So now on the internet, no one knows you're a dog. And this is the problem. So it's a fully digital society. So you can't trust what you see because anyone can be anybody, okay? You can't trust what you hear and no one trusts what you say, okay? So this is the Web 1.0 problem in general. Now here is the irony. In the Web 2.0 world, everybody knows you're a dog. Why is that? Because, well, I edited this. So the solution is, the problem is, well, people don't read the terms of service and they don't hear about their data being breached. And then they wonder how the hell did their information get to that, leak out. Okay, so and this is the problem because the companies in the Web 2.0 and even now, right, they hold our data, they own it, and I think it's not too far to assume that they will use it without your permission, right? Like, did you know that you were part of a Google internal survey to see how many developers use Gmail? I'm pretty sure you don't. But your data was used, right? So in the Web 3.0 world, it's your data, you should own it. So here is the problem. There is a balance between trust and privacy. Okay, so on one hand, you say, hey, you don't respect my privacy. Okay, well, on the other hand, it's like, well, you just got to trust what I say. So, well, this is one dimensional argument that you can have more privacy, but you will have less transparency and therefore less trust. You have more trust, but then you show more things and then there's less privacy. So is there a way around this? Okay, so yes, there is. We kind of talked about cryptography before. So a whole suite of new things like privacy enhancing cryptography called or privacy enhancing technologies, PET. Okay, you can check that out. So in addition to PET is there's a lot of terms being thrown around, so I am focusing on this one because this one is pretty good. This is from the Monetary Authority of Singapore, and they call it the foundational digital infrastructure. So they're saying that, well, we need to create a digital infrastructure because the world is moving online, and COVID kind of accelerated that transition. Okay, so it's Pandora's box is open, it's not going away. So what will digital infrastructure kind of need? Okay, it needs those four things. Okay, number one, you need a trusted digital identity. Number two, you need consent and authorization. Number three, you need payments. And number four, you need some sort of data exchange. Well, I would modify to say that it's not simply an exchange. Sometimes it is one way. Exchange implies both ways. Okay. And then the key questions on how to shape this core digital identity: who will be the users and what are their needs, what are their local preconditions, and what is needed to establish trust. So remember back in both the dog problem, right? That no one knows who you are and everyone knows who you are. At the end of the day, your data is leaked and it happens to be your data, right? But if, we say in the world of cryptography that no one trusts each other, and you don't even trust yourself, right? So how do you establish this trust? This is really the hard part about Web 3.0, okay? And some sort of a digital identity. So in other words, digital identity needs to be trusted and also needs to be controlled by the user. So how to effectively launch this digital, so that identity, this is their way of going to market, etc. So now we're going to focus on these 4 points. Okay, those 4 points, they are rearranged. It looks like a stack like this. Okay, so in the beginning, I did say that a lot of people would say blockchain solution, you can trust it because it's on blockchain, of course, right? No, it's not that easy because it depends on how those information is entered into the blockchain, and of course, like who is using the blockchain. So now this dimension of they need to be first identified, right? So in real life, I'm looking at me. Hey, honestly, I'm looking at you guys right now. I don't know if I have deep fake filters on. I could be like, deep faking myself too, right? No one knows, right? This is possible, right? Obviously, the quality is not that great today, or the good quality ones are not available to all of us, right? But we're getting there. The whole point is that in the digital world, how do you know who you're dealing with? Okay, that is the point of digital identity. Second is consent. Okay, with a consent module, then you can say, oh, I'm going to participate in the survey. I'm going to give my identity information, but not everything, just some things. Okay, whatever is relevant. I give consent because I'm giving this relevant stuff for the survey because I'm going to get something good. Maybe it's a lucky draw or free, I don't know, whatever. Okay. So consent is important because in the previous world, there's no consent. Your data just sitting on some company server. That's it. So once you have consent, then you can have, you need consent to have payments, right? Like even now, you use a credit card, you have to provide consent in order for the payment to go through. Oh, that interestingly enough, not every interaction requires identity. So just like I said, a credit card does not require identity. But of course, if it is a verified transaction, probably you would get a much better rate. Well, there's a lot of savings and benefits get passed down to the consumer if companies want to stay competitive, right? So there's an incentive to do that. And finally, data interchange. So payments is kind of like money interchange. Data is like, it's data interchange, and also documents as well. And there you see it, this blue blob, this is what needs to be added between the blockchain and the blockchain application. Without this, your blockchain application basically it launches and no one trusts it. That is a disaster. Okay, yeah. So even though this says internet, so internet is the underlying infrastructure, and then the World Wide Web is built on it. Blockchain is built on it. Yeah, and this is basically how your blockchain application should be architected in a high level way. Now, there's a few things I want to wrap up. So trust over IP is this is a TOIP. This TOIP thing is framework and check it out. Okay, TOIP. Okay, so long story short, this is a 4 levels of trust, machine trust and human trust, and it's divided between technology is required for this trust to be implemented and some governance. So governance in a nutshell is there are some things that technology cannot solve. Remember what I said at the beginning, right? Technology cannot solve everything. So when the technology is lacking or it's going to fail, something needs to pick it up. And this is the offline or off-chain governance, offline governance, right? All these are kind of like supporting system that complement. You need to have governance in order to support the technology. So for example, right? So on the public utilities layer, this would mean like blockchain, okay? And then the governance side would be, well, what blockchain are we going to use? Okay, well, how do we decide what blockchain to use? Could be blockchains, like, a lot of these applications, they're actually blockchain agnostic, right? So is there going to be a requirement for inter-chain operability? Okay, so peer-to-peer connections, is there a framework that we should follow? Is there some hardware and software requirements? So this is an example of like governance framework. One that I want to focus on is the third layer, technology layer. This is called verifiable credentials. So briefly explain what that word means. Verify means, well, there are a lot of synonyms to verifying, right? So there's verification, there's validation, there's authentication. I mean, you've seen these words kind of floating around. There's a good old like inspection, checking, right? Yeah, so, okay, long story short, verification is this one that elicits the strongest trust because you can trace it all the way back to where that thing originated from. In this case, is where it issued, okay? So an example would be like, here, you have this very official looking institution issuing this very official looking thing to a holder, and they hold it in their digital wallet. So remember what we said, Web 3.0 is all about the wallet, right? So just like a real wallet, this is where you hold all your important cards, digital cards, okay? So this is a digital verifiable credential, okay? And it's verifiable credential because it all needs to be traced back to the issuer, okay? So when someone needs to verify, then they'll ask the holder for a proof. Hey, can you provide proof of whatever I'm asking for? And they say, okay, yeah, they fish out the whatever the credential that would have the whatever they're looking for. So what are they looking for? For example, 7-Eleven could be asking if you're over 18 if you want to buy a beer, right? So, today you would be like, well, you fish out your HKID, your passport, you show them the birthday, they do some math, hopefully they get it right, and then they, oh, you're over 18. But, all you needed actually to do is somehow give them a proof that you're over 18. You don't need to tell them your birthday. You don't need to tell them your date of birth. You don't need to tell them your age even, right? So this is what verifiable credentials should be able to do. And all this technology exists out there. You just need to read about it to really understand it. I'm just putting on the map for you. So how does this trust connection? There's no integration needed. Now, this is the key part about this kind of protocol, this framework, okay? In the past, Web 2.0 world, the issuer and the verifier would need to have some sort of API where systems talk to each other, right? It's like, this guy is sending me this stuff. How do I know this stuff is like, how do I know he didn't like Photoshop it or change it or whatever, right? Well, those systems would need to talk to each other. That would be the Web 2.0 answer. The Web 3.0 answer, the Web 3 answer would be like, well, when the credential was issued, it goes into a data registry, okay, which is also governed by some form of governance, okay? So when the verifier does this verification, it also does a lookup, okay? And they want to see if this thing was issued indeed by that issuer. So they compare the public keys. They also compare other stuff. Like, for example, this issuing this verifiable credential basically is hashed. So they can compare the hash as well. So yeah, as you guys all know, hash is a one-way function. It's deterministic. So as long as the holder didn't change anything, then I should be able to find the hash in the registry, right? So that is how verifiable credentials work in a nutshell, okay? So this is also like very simplified into this diagram. So an issuer issues verifiable credential to a holder. and the holder becomes a prover, and they have to send a proof over to the verifier. Verifier trusts the issuer because they can look it up in the registry, and then they can see the information. They can see the information and fulfills what they need. You're over 18, and they also can see in the verifiable data registry that, oh yeah, this stuff that was passed to me that I'm satisfied with hasn't been changed, and it is also issued by that issuer. All this, see that this is nice history. You can trace the trust, right? So this is how blockchain is used. But of course, not every solution needs verifiable credentials, but this verifiable credential framework works for a lot of solutions. You'll find this in a lot of things. You'll know that your solution has failed if the verifier needs to contact the issuer for whatever reason, then it's like, what is the point? Just feed the whole purpose of all this fancy shit, okay? Just go do the Web 2.0 thing. Okay, so this is a solution in a nutshell, okay? Final thing I want to leave you guys with is something called Pan-Canadian Trust Framework. They have a beautiful website, go into details of this. So you guys may have, actually, we'll show in the end. My company is called Atomic Knowledge Proof, and it was derived from this atomic processes concept that was championed by this Pan-Canadian Trust Framework, okay? So this here is all about the different levels of trust. So back in this, so with this checking of the issuer, so an issuer could issue different things that you can determine by proof, right? Okay, but another way to say that, a lot of your IDs may have your birthday on it, okay? But which is the trusted one, okay? It's not up to you, the solution designer, to decide. It's up to the verifier to decide. So the best thing you can do is to provide some way for the verifier to make their own decision. And this is what the trust framework is for. You have different levels of assurance. So for example, you have this in real life too, right? Like 7-Eleven will accept passports and ID cards because they want government issue ID, right? If you send them a school card, I don't think they will accept, right? But if you want to go to a club, I think you can bring a student ID. So it's different levels of trust assurance, right? So you also provide the same thing in your solution design. Final, I did say that was final. I lied. This is the final one. So this is the final concept to impart with you guys. This is called a DID, decentralized identifier. This is, long story short, like URLs. URLs are addresses, right? But URLs are not permanent. DIDs are permanent. In the world of blockchain and Web3, well, permanence is a very important problem because it helps with provenance and contribute to trust. And that is the framework for Internet of Assets, right? You don't want things to just disappear on you. So you would be able to read more about DIDs and find out how to incorporate that into your solution design. Highly recommended. Okay, and then this is the end of this section. Any questions?
I have one question from Rishabh.
Yeah.
So he has a theory question related to consensus. So when deciding on a consensus mechanism, how do you decide whether you want the consensus mechanism to take place while mining blocks from consenting miners, or mining, or while validating the transaction?
Okay, so I am assuming that this hackathon is about applications on the application level, correct? So let's look here on this stack here. So your question concerns level 1, whereas you guys are designing level 4. It's not about like level 4 is better or worse than level 1 or vice versa. But when you are doing an application level design, you would not care about the consensus mechanism. You may have a governance framework to say that I would require certain attributes to my consensus. But in general, if the blockchain comes to a consensus, it will fit your requirements in the application, on the application level. Okay, consensus, you're looking for 2 things, liveness and consistency, okay? Consistency is quite straightforward. Like if everyone has a different copy of the thing, then of transactions or information, right? Then there is no consensus, like what the hell? Liveness means like it will not, it's like we have liveness, we are alive, okay? So the opposite of that would be dead. So what does dead mean in the consensus mechanism, right? It means the thing's stuck. So if, let's say we have a, yeah, okay, proof of work. It goes around, actually, that's too complicated. Okay, liveness means like it won't get stuck. So there are certain situations where a decision, like, a committee might get stuck on a decision, like in real life, right? Like that's a good analogy, right? Let's say the PolyHacks team, they want to make a decision. Let's invite Gabriel to do this talk. And let's say half of them say yes, half of them say no. Okay, they're stuck. Okay, unless they have, well, hopefully they have a, well, in case of 50-50 stuck, then the chairperson, Scotty, will make the final decision. Then it's not, then you have liveness. Okay, without that, you have no liveness. Then there'll be no consensus. So that's what you need to look for in consensus mechanism. Yeah, proof of work and proof of stake are just like two protocols possible. There's also practical PBFT, Byzantine fault tolerance. Yeah, there are RAF consensus. There are a lot of consensus protocols. In general, if you want to design a consensus protocol, that's very hard work. A lot of people, not a lot of people can do it. Not a lot of people can do it because it involves a lot of cryptography and mathematics. Yeah, but in general, if you are doing the application design, you don't have to worry about that. Yeah, I hope that answers your question. Oh, and also you don't want to mix up consensus mechanisms with your actual like ecosystem. There are a lot of applications that are kind of like, oh yeah, we'll need to have some sort of token economy, and then just gonna, yeah, tying the application level with the consensus level is just a recipe for disaster. Like there's reasons why you want to separate different levels because they're operating at different levels. It's kind of like, imagine like every time you have to use a computer, you have to like moderate how much like volts or your ampere is coming out of your socket. That's it's crazy. That's why you don't want to mix up these layers. Okay, any other questions? But feel free to reach out to us, Scotty, for hackathon needs, and to me if you would like a second opinion on your work. So yeah, thank you guys for coming.
Thank you so much, Gabriel. Would you be available for like a quick Q&A after the session?
Yeah, that's now, right?
Yeah.
Yeah.
Like right now. Okay, so I hope you guys enjoyed the session. I personally really enjoyed it. I think I learned a lot. Hopefully, I also want to hack for the problem statements that we've revealed for this hackathon. But do you guys have any questions for Gabriel today? Maybe we'll stick around for like 5-10 minutes. Have any discussion? Yep, so Gabriel, maybe I'll ask a question while people are thinking about their questions. What do you think of our problem statements this year?
Your problem statements were, please remind me again. Blockchain, smart cities, and something else.
Let me share my screen.
Sure. Fintech. Oh, yes, that's right.
So for blockchain.
Yeah, okay. So lack of alignment in responsibility and sustainability across supply chains. Okay, yeah. So number one is very similar to the MTR scenario. Number two, how do we implement NFT technology in governmental institutions? Also be used in basically all three of those scenarios, right? NFT is just one way to, it's one tool in the technology tool, the tool belt. Identifying experiences. Okay, this is the Mike Ross problem. This is scenario 2 that we covered. Yeah, so I think after this this session, I think we should see some pretty good hacks and good solutions coming out of the group. Can't wait to see
Yeah,
them.
I feel like people who haven't come tonight are actually at a disadvantage. Yeah, so the 50 people came today. Good thing you came. Okay, so you have a question. Okay, so Ali Beck asked, what is the point of doing solutions on blockchain if it can be done on a centralized system that we trust? Or is it inherently impossible? Because smart contracts are pretty much high-level scripts with input variables that can be, he uses quotes, can be used even outside of blockchain.
What is the point of doing solutions on blockchain if they can be done in a centralized system? So this leads back to the first thing I said is centralized or decentralized is nothing like inherently good or bad. Is do you need it, and how much do you need? Okay, so let's use our pandemic controls as an example. I think we all know, we have to use that leave home safe thing. Our health records are kind of like locked into there, right? In regards to COVID. Yeah. So the design of that system, is there are inherently a lot of imperfections. Let's just say. But that is okay because at the end of the day, we trust the entity that's running this whole thing, the Hong Kong government. Okay, so according to the Hong Kong government, we would be, labeled as a public threat or not with respect to COVID, depending on our vaccination record and our leave home safe record. Okay, but let's say the border opens with China. Okay, then the authorities in mainland, they would be like, they may call out some issues with how Hong Kong does its tracking. And likewise, Hong Kong may have some issues with how mainland does its tracking, right? And replace mainland government with any government. Let's say they do, they were talking about a Singapore, Hong Kong travel bubble, right? So why do why would Hong Kong authorities trust how Singapore is managing their pandemic? How do they manage their records? Conversely, how does a Singaporean government, would they trust our leave home safe records and our vaccine records? So the point is not to answer these questions, but rather this points to a need for some sort of a relatively decentralized system that involves these highly decentralized organizations to contribute to a single truth. Okay, and that single truth in this case would be the veracity of COVID records, right? Yeah. So what Ali Beck is saying is, okay, there are certain centralized systems that we trust. Well, remember, trust or not trust is not up to you, the designer, to decide. It's up to the verifier. And in some cases, that would be the user. So you cannot just put a system out there and say, this is the system, you got to trust it. Okay, so it's up to the end user to decide and a verifier to decide. Okay, so yeah, you may, like, just because you may trust this system, someone else may not. So this doesn't mean a centralized system can always be trusted. Of course, not. That's what people are saying, right? Can you decentralize the trust so that more people can trust it? Well, yes, it depends on how you design that system. So I would say that is not impossible. It is about what is meant to be achieved and what balance of centralization and decentralization you want to do. And the last part about smart contracts is more an implementation thing. Okay, smart contracts is just to implement the solution strategy that you have formulated. And there are off-chain and on-chain components. Like, for example, you do need oracles to provide some information besides like things that are not on-chain. Right? Maybe I'm confused, but why is the MIDAS system considered decentralized if the verification lookup table is stored centrally at the DLT? Well, yeah, that's actually precisely one of the reasons why Midas is considered not successful, even though they tout themselves as a blockchain solution supposedly decentralized. Long story short, it's actually we don't know because they never specified who would be the how is their DLT governed? Okay, that would be a question you would ask those Midas people. Okay, yeah, stored in the DLT. The DLT is inherently supposed to be decentralized. Sorry, distributed. It's distributed. The D in DLT is distributed ledger technology. Does not imply decentralization. It explicitly like that. Though their design principles, they are telegraphing that they have some sort of decentralization because at HKFI, the Insurance Federation of Insurers, they are supposedly a group of insurance companies. Do the insurance companies actually run the part of are they part of the nodes in the blockchain or in the DLT? This is what they're implying, but we're not sure. Yeah. There's a few processes that run through a certain gateway. Is that gateway controlled by FI? Well, we don't know. So how centralized or decentralized is Midas? We don't know. We can only make some assumptions, educated guesses. Okay. And at the end of the day, Midas's failure is not about how centralized or decentralized it is. It's actually about trust. So when you look at your blockchain solutions, you have to be very, very true to yourself. Does this solve trust issues? In the case of Midas, there's a lot of places where someone could add bad data to the chain, and that would actually erode trust even more. You could even argue that Midas made the situation worse by introducing these loopholes. So so remember I said if the verifier has to go back to the original issuer to find out what's going on, then clear failure. If your solution is introducing more problems, then, well, it depends on what kind of problems they are, but shouldn't be counter to the mission that you were set out to solve.
Okay. Yeah, thanks so much, Gabriel. So for everyone here, just a couple of program details moving forward for PolyHack. So as you guys know, we are a two-week hackathon, and we offer mentorship throughout those 2 weeks. So for tomorrow, we have 3 mentors giving us time. So we have capacity for 9 teams to get mentorship tomorrow. So I know everyone here are still a little bit confused about our problem statements and trying to find teams. And I think that's why people are not really coming to get mentorship, but don't worry. I know at this stage, you guys are very, very fresh at it. So the mentorship tomorrow will be very casual. So let me just introduce our 3 mentors for tomorrow. We have Mr. Andrew Chen coming in. He is a managing partner at Arian Ventures. He's done a lot of things with mobile web solutions for consumers and restaurants. He's also done a fintech startup, and he's a really cool person. So I think if you guys want to know more about his projects, then maybe he can give you some insights on your ideas at this early stage. It'd be a really good session. We also have Mr. David Lee, who is was a CEO at G2000. So he's also a really, really cool person. And we have Professor Jack Kuhn, who personally has helped a lot with this PolyHack. And he has a lot of good insights on fintech and DeFi and blockchain. So if you want to get any mentorship immediately tomorrow, please go to this link on PolyHack Mentors and book Andrew Chen, Jack Poon, and David Lee. And remember, prior to the session, you also have to submit a pre-mentorship form so that the mentors kind of have a general idea who they're meeting. please make sure to do that. It'll take like literally 2 minutes at this stage. Okay, so I guess we still have a lot of questions, Gabriel. I guess it was a very riveting session. So maybe Gabriel, you can just stay a little bit longer, or you can go off and then I could forward these questions to you and then we could have a discussion on Discord. So for people who want to mingle a little bit longer after the session, we have the voice channels on Discord open. So you can join any of our Discord channels like Pikachu, Bulbasaur, any of the channels that you like. So, okay. So Gabriel, do you want to answer one more question? Or
yeah, sure.
Okay. Yeah, so maybe let's go to Rishabh, who asked first. So he asked, does mocking a smart contract pose security risk?
Yeah, can you let him speak? I'm trying to understand the question, the problem.
So Solal is it enabled? I think it's enabled by default. Sorry, we'll just check real quick. Yep, I think he can speak. So Rishabh, if you want to unmute yourself and ask in person, that's okay too.
Hi, can you hear me?
Yeah.
Yep.
Am I audible?
Yeah.
Yeah, so I did write about why mockings are deployed. Can you hear me?
Yep.
Yeah, so for instance, what happens is, so I usually use Hyperledger when I'm like developing blockchain applications. So I usually end up having a lot of like, external dependencies because like, as you know, blockchain libraries are very fragmented. You have one in some other repository and one in at the other end. So I often have to end up like creating a benchmarking tool of sorts using mocking. That's like you make a copy of a contract and then you have like full control over it as a developer. But the developer protocol is separate, as in like any person who is a developer automatically has access to the mocking, to the mock contract. So does that like pose a risk to um to the production network, or is it fine? Is it controlled? I don't know about the depth or like how deeply this mocking principle goes. So I'm not very sure how it works in the industrial sector.
Okay, I'm still not quite sure what you mean by mocking. It sounds like you, entity A and entity B have the same smart contract or code or whatever, right? So then is it possible for entity B to pretend to be entity A when deploying it to live production? And then people go
Yeah,
to
yeah. So you essentially only mock a contract because like you want to test it, but even though you just that's your purpose, what ends up happening is mocking usually gives you complete control access over the contract. So you are essentially in full control of the smart contract when you're mocking it.
on a test net though, not on the
No,
production.
it's deployed, right?
Well, this sounds similar to phishing to me. Well, in the live net, you would be able to know the key of you'd be able to at least identify who deployed the contract. Yeah, there should be some ways to know whether the contract deployed was to who you expected to be. If you're going to test it in the test net, those addresses and parameters would not be the same as live either.
Right. So like according to the PolyHack rubric, in the technical viability section, it says that the prototype implements a co-functional reliably and many additional features. So for instance, say I implement mocking in my solution, to like showcase the benchmarking process and how like efficient my application is. So would that like the fact that that poses a security risk, will that have any effect on my score, or would that just like not be considered because it's just benchmarking?
Well,
Or
this is
that
a
affect?
score issue, but
Yeah,
if I were to give my opinion, I think, well, first of all, I think if the test net and the live net does not have clear security, like there's security issues between the live net and test net, that's not the application developer's fault. That's the platform's fault.
so if I do end up including it in my deployment plan, as in if I say that I plan to use a like handle control access of the smart contracts to developers when I'm actually deploying my product, would that have a negative impact on my score assessment?
I think you should have some best practices when you deploy it. So you have
Alright,
adequate UAT, user acceptance testing, and your internal testing. Like pretty like, testing is actually usually like quite like obvious things, right? But having a checklist is very useful. If there is some, like I said, there's something wrong, like if there is some vulnerability with the platform, like with Hyperledger itself, that's not your fault. Efficiency, glad you brought it up. Efficiency isn't a problem for blockchain. Blockchain's job is to assist a single truth, trust, okay? And efficiency may not be part of that consideration. It might be a nice to have. In some cases, efficiency is actually not good. Like there's reasons why a bank may slow down transactions so it doesn't go through instantaneously because there are some compliance and regulation issues. So yeah, not all the time is efficiency important. If you had to choose between trust, privacy, and efficiency, I think trust is the showstopper, and privacy is probably more important than efficiency. Though there are in some cases where like if, for example, if you handle like section 3 with the CVs and stuff, like that's also personal information too. But that compared to like if you're transferring funds on your platform, then I think the security and privacy and trust is way more important than efficiency.
Right. So I just mentioned it in the document testing. It won't matter anymore, right? That's it.
Yeah, you mentioned benchmarking, right? So it depends on what you're benchmarking with. If you're going to do blockchain applications, your benchmark should be on trust. Like for example, the Midas situation is like the benchmark should be like, well, trust and yeah, trust, right? And based on that benchmark, Midas did not do very well, right? If you do efficiency, you can argue Midas did better because it's QR code. What's the point of having an efficient system if it's not trustworthy?
Right.
So
I didn't refer to efficiency as in like product performance. I refer to efficiency as in like the quality of code. Like some Hyperledger modules, like they help you have more modularity in your code compared to others. So like would that count towards
Okay,
efficiency?
again, this is
That's
this is my opinion only and not the contest. But if it's a hackathon, I think it's more important that it works. So it works means, to me, it means like solution design works, and then secondly, the code works. Okay, if the code is not efficient, it doesn't matter. It's just the first prototype. Doesn't have to be efficient.
okay. Thank you.
thank you so much, everyone. I'm gonna have to cut the session now. Thank you so much, Gabriel. I think this was such a great session. Thank you.